Page 439, Lesson 7.4 is on division properties of exponents. So if you look at this example, we have 4 to the 5th divided by 4 cubed. If you think about what's happening, then you could say 4 to the 5th is 4 times 4 times 4 times 4 times 4. 4 cubed is 4 times 4 times 4. And then we can reduce the numerator and denominator. We can reduce by factors of 4 3 times. And what we're left with is 2 factors of 4 in the numerator. And 4 times 4 is the same as 4 squared, or 4 to the 2nd power. If you look at what we did, and if you look at what the original exponents were, you might notice that our exponents were 5 and 3. Our final exponent was 2. So what we can do then is when you divide like bases, you can subtract the exponents. Similar to when you multiplied like bases, you added the exponents. So you can see some more examples down here. 2 to the 6th divided by 2 squared. Subtract the exponents, that would be 2 to the 4th power. You could just think of, you have 4 more factors of 2 in the numerator. Their second example, you could subtract the exponents. 4 minus 7 is negative 3. That's x to the negative 3rd power. Normally we don't want to have negative exponents in our answer, so that would be 1 over x cubed. A different way that you could do this problem is, if you look at this to begin with, you could say we have more factors of x in the denominator. How many more do we have in the denominator? And the answer would be 3. And you could just directly go to this answer, 1 over x cubed. We talked about earlier in this chapter about if you had something to the 0 power, it's equal to 1. So this now gives us the opportunity to re-look at that. So for example, if you had 2 to the 3rd power over 2 to the 3rd power, that would be the same as 8/8, and 8/8 is equal to 1. Makes sense. If our numerator and denominator are the same, the fraction's equal to 1. If we use this idea now of subtracting our exponents, we could say this is 2 to the 3 minus 3 power, which is like 2 to the 0 power. So if both of these things are true, this proves kind of in a different way that if you have something to the 0 power, it's equal to 1, as long as you can't have 0 to the 0 power. So if you look at problem 1, they want us to simplify this. So x to the 5/2 over x squared. Since we're dividing like bases, we can subtract the exponents. You could get a common denominator here. So this would be like 5/2 minus 4/2, which would be x to the 1/2 power. Part B, we have 2 different variables. Rather than doing what the book's doing, I would just look at where do I have more of a certain variable. So with the m's, I'm just going to look at it and say I have more m's in the denominator. How many more? 3. And I'm just going to say I'm going to be left with m cubed in the denominator. With the n's, I have more n's, factors of n in the numerator. And how many more? 1. Or you can subtract 4 minus 3 as 1. Okay, but to me, when you're working these out, it's just easier to look at where do I have more, and then you don't have to even worry about ever getting a negative exponent unless there's 1 to begin with in the problem. So let's look at the got it. Feel free to pause these if you need more time to think about them. Part A, we have fraction for exponents. So I'm going to get common denominator, which is 4, and then we can subtract 3/4 minus 2/4 would be y to the 1/4 power. Part B, same idea. So we can subtract exponents here. 7 halves minus 6 halves would be d to the 1/2 power. Part C, the k you can put as k to the 1st power, and then if you subtract those, we've got 5 more factors of k in the numerator. With the j's, we actually have more in the denominator by 3, so that would be k to the 5th over j cubed. And part D, we actually start out with a negative exponent here, so I'm just going to rewrite this to begin with, and I'm going to get rid of the negative exponent. I'm going to move that to the denominator as a cubed. And then if you notice, all the a's are in the denominator, so that would be a to the 8th. And then we have more factors of b in the numerator. If you take 7 minus 2 is 5, so b to the 5th over a to the 8th. Okay, and you're welcome to, just use the rule of you're going to subtract the exponents when you're dividing like bases, but then you'd get a to the negative 8th, b to the 5th, and then you move it to the denominator. So not a big deal, just a little different route on working that out. And then part E is similar. We have a little bit more with the negative exponents here. But I just like to get rid of the negative exponents and then start working the problem out. It just seems easier for me to work through that way. X to the 4th over x to the 4th, basically those cancel out. And then we've got, with the y's, we have more y's in the numerator, so that'd be like y to the 4th. Z's, we also have more in the numerator. This is z to the 1st in the denominator, so that would be z to the 7th. So we don't even need the fraction bar anymore. Problem 2 talks about how we can work through problems using scientific notation. So population density describes the number of people per unit area. During 1 year, the population of Angola was 1.21 times 10 to the 7th people. The area of Angola is 4.81 times 10 to the 5th square miles. What was the population density of Angola that year? So finding the population density, we're taking the number of people, the population, and we're dividing it by the area, and then we get how many people per square mile that there would be. So what you can do on this is you can just look at the numbers that are out in front. You can make those into a fraction. These both have 10 to a power since they're in scientific notation. If you divide like bases, you can subtract the exponents, or you could just say I have 2 more factors of 10 in the numerator. That would be 10 squared. If you divide this out, it comes out to be about 0.252 times 10 to the 2nd power. Every time we multiply by 10 moves the decimal 1 spot to the right. So this is kind of like just multiplying by 100 is what we're doing basically. And so that would be 25.2 people per square mile. So the got it 2 is very similar to this. It's basically the same thing, just different numbers. So population divided by the area. So if you divide that out, it's about 1.69. I'm sorry, this should have been 10 to the 4th in the denominator. So this would be 10 squared, and then that would be about 169 people per square mile. Top of the next page, they just talk about how if you have a fraction to a power, you could just say, it's x over y cubed means x over y times x over y times x over y. But then if we condense that all into one thing, we end up with x cubed over y cubed. So basically what that tells us is this property for raising a quotient to a power, which says that if you have a fraction to a power, you can take the numerator to that power over the denominator to that power. So they give us some examples. 3/5 cubed, that could be the same as 3 cubed over 5 cubed. X over y to the 5th would be x to the 5th over y to the 5th. A over b to the 1/2 would be a to the 1/2 over b to the 1/2. Sometimes that allows us to get more of a simplified form for our answers. So if you look at problem 3, what's a simplified form of that? We could cube both the numerator and the denominator, and so that would end up being z squared over 125. Z squared, if you follow the book's method, you could multiply those. That'd be 6/3, which is the same as 2. Otherwise, you could do z to the 2/3 times z to the 2/3 times z to the 2/3, and then multiplying like bases, add your exponents, you'd get the same answer. So if you look at the Got It 3, Part A, a simplified form of that. The squared on the outside, we can then square the numerator, square the denominator, and that would be 16 over x to the 6th power. The bottom of the page talks about if we have a negative exponent and how that works, if we have a fraction to a negative exponent. So if you wanted to follow the rules kind of how this works, normally we'd say if something's to a negative power, we can put it in the denominator to make it positive. And then since the whole fraction is to the n power, we could put a to the n over b to the n. And then you could look at this as 1 divided by a to the n over b to the n. And then we could keep change reciprocal. And then we end up with b to the n over a to the n, which is the same as b over a to the n power. So long story, but this is one thing that we can say then for working that out. Another way you could do this is you could say, this way to me is a little bit simpler. You could just say, let's take the numerator to the negative n, let's take the denominator to the negative n, and then if I want to get rid of the negative power, I'm going to put them in the opposite parts of the fraction. To me, that's maybe less memorization. It's more just doing what we've already done and being able to come up with that. So with that idea, if we look at problem 4, I would probably go this route of saying, let's take this to the negative 3rd power, let's take this to the negative 3rd power, and then to get rid of the negatives, I'm going to move them. So the numerator moves to the denominator to make that a positive 3. the denominator moves to the numerator to make that a positive 3 exponent. And now we can just use our rules we've talked about. So y to the 4th cubed, we would do 4 times 3 is 12. In the denominator, this would be like 2 cubed times x to the 6th cubed. 2 cubed is 8, and then x to the 6th cubed, 6 times 3 is 18. And there's nothing more we can do with it at that point. So if we look at the got it 4, they want us to simplify this. Like I said, different routes you can take. I'm going to go ahead and just say I'm going to make the numerator and the denominator to the negative 2nd power. And then to get rid of the negative exponents, we can bring them to the opposite parts of the fraction. And that would be 25b squared over a squared. So if we look at the lesson check number 1, they want us to simplify the expression. So for number 1, I would just look at where do I have more factors of y, and that would be in the denominator. How many more factors of y do I have there? And that would be 7. 10 minus 3 is 7. So 1 over y to the 7th power. If you just use the rule of subtracting exponents, you'd get y to the negative 7th, and then you could convert it to 1 over y to the 7th. Remember, it's not considered simplified if you have a negative exponent. Number 2, we can cube the numerator and the denominator, and that would be x over 27. Number 3, I would just go ahead and bring that exponent to both of those. And then let's get rid of our negative exponents. So n cubed over m cubed. And number 4, bring that exponent to both of those. I'm going to get rid of the negative exponents. So that would be 625 y to the 16th over 81x to the 8th. If we look at number 7, Ross simplifies a cubed over a to the 7th as shown to the right. Explain why Ross's method works. So this is kind of just our other method we've talked about, is that, we have more factors of a in the denominator, and so you could just take away the 3. It's kind of like we're taking away the 3 factors in the numerator, kind of by canceling out 3 factors of a, and then that'll give you 1 over a to the 4th. So this gives you an idea of how to work with division properties of exponents. Have a good day.